Hello guys, welcome back to my fifth session of NEET series 2021. I hope people are preparing hard for this exam which is on 12th September 2021. Okay, now after the fourth session, the topic which I have taken for today's discussion is modern physics. I hope you people are aware because we have already discussed which are the topic which we are going to cover in our session 1. Now look here, when it comes to modern physics, you need to understand that there are a lot of formula which you need to mug up and there are a lot of relation based questions which can come during the exam. So the strategy to solve this particular chapter should be a bit different. That's the reason our strategy is also going to be different, because there is all the possibility that you will spend a minimum amount of time in reading this particular unit and there's a maximum chance that you will get the correct answer. But for that particular thing, you need to understand that how we need to approach a one particular topic. Now in modern physics, as we know that there are 3 chapters in our NCERT book. The one, dual nature of matter and radiation, and then you have atom, and then you have nuclei. Dual nature of matter and radiation and nuclei are small units which will not consume as much time as one going to be consumed by your atom chapter. So here my aim is to explain you this atomic structure particularly, because there are a lot of various relation in atomic structure. So we will learn every single formula for atomic structure in this particular session so that we should be prepared for this exam. Now, instead of taking a question answer approach, I am going to tell you all the relation and the modification which you can remember. Because remember, in modern physics, you can save a lot of time if you know a lot of relations, and that relation is actually very easy to remember, because when you keep on practicing various numericals, what happens, you will use the formula again and again. So most of the time it happens that people actually, the moment you read the question, the value clicks. So that is the best way to reduce the time in this particular unit. Now when I'm going to start with this particular modern physics, let's see how we have the basic introduction of our atomic structure, which I'm going to start over here today. Now first thing which I need you to understand when it comes to the atomic structure or this particular chapter, atom. We know that every single material is actually consists of an atom. So from 20th century, from the beginning, we have a lot of curiosity about this particular structure, that how exactly the atom look like. And there are various people who have actually proposed their theories in this particular field, and what happens, some theories are accepted, some theories are rejected, but at the same time we need to understand that which are the drawback exists in that particular theory. There can be a question based on drawback also, so I would suggest that you should also not avoid reading the drawback for that particular experiment. Now when we have our very first experiment over here, which is Thomson model, and I hope most of the people actually remember the Thomson model as a plum pudding model, because I hope you people know that here we don't talk about the nucleus. The nucleus is something which is missing over here, and there are a lot of drawback in this particular theory which we understand by saying that it could not explain the atomic spectra, and at the same time it could not explain the absorption and emission. So the very first theory which has been proposed for atomic structure not been able to explain a lot of things which are related to the atom. So what we have done over the period of time, we have gone back to the other theories. So Rutherford model is the one where we have seen that Rutherford was actually one particular experiment he has done, the alpha scattering experiment, which is one of the very famous experiment we have, because we have the discovery of nucleus in this particular experiment. Now basically when you say discovery of nucleus, there are a lot of conclusion which has been given by the Rutherford model. I will not go in detail of every single point over here, but what you need to understand that Rutherford had concluded one particular thing, that when you talk about an atom is something which is actually a 99.9% is an empty space, and the entire mass of the atom is actually placed inside in nucleus. So you can imagine that how big the cloud look like, but this nucleus is so small which is present inside an atom. Now if you wanted to just simply compare it, if a football field you see as an atom, if you place a marble inside the football field, that is how you can visualize the atom as well, atom and the nucleus. Now this particular theory, when we actually perform this alpha scattering experiment, from there the various time there is a question which actually talk about the distance of closest approach. Now you need to understand that when you are projecting a beam of alpha particle on the nucleus, on the atom, or the thin gold foil experiment which we have done, where you actually project a beam of alpha particle on that particular sheet, what happened, there is one particular beam of electron which has been deflected by 180 degree, and that is the one who are actually exactly targeting the nucleus of an atom. So that is how the discovery of nucleus happens. So here what we need to understand, that this alpha particle which I have taken over here, which is having a positive charge, and alpha particle, I hope you know that it is actually 2 times of an electron. So electron, which is 1.6 into 10 raised to minus 19, if you take it positive, it is the charge of a proton. So alpha particle charge is actually 2 times of a charge of an electron. At the same time, when you talk about nucleus, where you can say the total number of charge, the charge of nucleus is positive, because we know that inside the nucleus you have proton and neutron. So basically what happened, proton and neutron, definitely the charge is consist by protons, and that is positive in nature. And if you wanted to calculate that, you can simply take your atomic number and multiply it by E. So that is what the charge of nucleus will look like. And what you need to understand, that there is going to be a electrostatic potential energy between the two. And when that electropotential energy, you can say, when that electropotential energy, the formula which you have learned in electrostatic, and for that I hope you people know the formula, that electrostatic potential energy U can be calculated by K Q1 Q2 by R square. Now what you need to understand over here, this R which I am writing, sorry, it is R square when we talk about electric force, but this is electric potential energy where you have only R at the denominator. When you write this particular formula, you need to understand, if you plug the value of Q1 and Q2, the way I have written 2E and ZE, what is going to be happen, this electrostatic potential energy in this particular case can be written as 1 by 4 pi epsilon, because the K stands for 1 by 4 pi epsilon. It is a constant value, we don't have to bother about, we already know this value. And this is also one more thing which I will tell you, in some particular formulas where you can remember the numbers. So instead of dealing with the variables, you can simply remember, because most of the physical quantity are constant over there, you can simply remember the number, so that you know the calculation time will be reduced. Okay. Now I have written here electrostatic potential energy of this particular case. Now you need to understand that this electrostatic potential energy we are getting, it is actually the one where I have written, this is the distance which I have taken between the two charged particles, where the projected alpha particle is going to stop for a moment. The reason is that whatever the kinetic energy you have given to this alpha particle, that kinetic energy is going to become equal to the potential energy between the alpha particle and the nucleus. So that is one particular distance R, where you can see that this is the distance of closest approach. So the formula is actually very easy to derive, because now what you can do, you can simply equate your kinetic energy to this particular formula, and you can find this value of R. And this R is nothing, it is your capital D. Usually the symbol is taken for this distance of closest approach. I'll write it over here for you. Now in this formula, if you should not be confused about that what exactly the ZE, which is the charge on nucleus, then you talk about 2E, which is a charge on alpha particle. Your R is distance between nucleus and alpha particle, and then you have your electrostatic potential energy. Equating your kinetic energy with this particular formula will simply give you the formula for this capital D. The R has been replaced by capital D, because I told you the distance where the alpha particle is going to be stopped, we simply replace that R by capital D, because that is what our aim is. Here one more thing, you need to understand that this K which I am writing, it stands for kinetic energy. So if you write this formula in terms of D, you can make D as your subject, and when you make D your subject over here, the formula look like K2ZE square over K. Now this K, remember, it is your kinetic energy which I have written over here, so there should be no confusion about the terminology. So when you read the formula, just make sure that you are actually reading the correct terminology over there, because various symbols and you should have their value and the meaning. Now in this formula, if I have to break it, the Z stand for your atomic number, E stand for charge of electron, which is a known value, and atomic number, definitely whenever some element is given to you in chemistry, you people have also learned about atomic number, atomic mass. So I don't think there should be any confusion about identifying that atomic number of that particular element. Now when I say charge of electron, we know that it is 1.6 into 10 raised to minus 19, so we can use that particular value over there. And the K stand for kinetic energy and alpha stand for alpha particle. So this is how the Rutherford experiment, the thing which we need to know from the Rutherford experiment. So that's it, what we need to know. Now, when we comes to the drawbacks of Rutherford model, because this model also was not being able to justify all the things which we actually see for one particular atom. So the various thing which actually make it fail, the very first thing is actually the revolving. Here you need to understand, I have written electron revolving around the nucleus should continuously radiate energy, and hence the electron should spiral before colliding with nucleus. What you need to understand by this particular drawback is that Rutherford was not being able to explain that why we have stable orbit, because when you talk about an atom, you have various orbit around the nucleus, and electrons are the one which are revolving around the nucleus. But according to Rutherford, if the continuously the energy is going to be radiated by the electron, definitely it is going to be spirally small, and then it will fall into the nucleus because of the electrostatic force exist between the nucleus and electron. Why I am saying electrostatic force? Because nucleus, something which is positive in nature, electron which is negative in nature, definitely the two are attractive towards each other. The second drawback which we have over here, it would emit continuous spectrum as per Rutherford, but in practical it shows line spectrum. This is also one more thing which we are going to discuss in detail, that what exactly the spectrum diagram look like for hydrogen. So this was also not been able to explain by the Rutherford model. So there are various drawbacks which we can remember. I told you from exam point of view, from NEET point of view, you people need to understand the experiment, the formula, and do remember the drawback. Sometimes there is a direct question or a reasoning based question can come in this particular manner, that you might need to recall the drawback which you have studied in that particular experiment. Okay. Now when we go to the next part over here, which is Bohr model. Now look here, the one which you have to study in detail is the Bohr model, and Bohr has actually given this entire thing into 3 postulates, and these postulates are very important. Definitely you people have learned postulate again and again. I will not get into the exact statement of what these postulates were, but what my aim is to make you understand that how exactly we need to visualize those postulates. So when I talk about the 3 postulates, there is something which I have written which will be easy for you to recall, that the first postulate is actually able to explain us something about that why there are stable circular orbit present in a nucleus. For that, the Bohr has simply taken that your electrostatic force should be equal to the centripetal force. So here when you talk about electrostatic force, which can be written as K Q1 Q2 by R square. If I talk about nth orbit, okay, this will be a general formula. So centripetal force is something which can be written as mv square by r. So what you need to remember, that this square and r will get cancelled, and you can simply relate this particular formula over here, that electrostatic force is going to provide this centripetal force, and that's the reason the electrons are revolving. Because we know one particular thing, whenever there is a circular motion is possible only when you have a centripetal force in a system. So here this centripetal force will be definitely provided by the electrostatic force which you have between the two. So that is the way we are going to remember this thing. Now one more thing what you can do, you can actually, this charge value which I am writing, I hope you people know that when you come to the charge, the one is having the charge as E, the electron which is moving around the nucleus, and the nucleus charge will be Ze, so it will become KZe square by R square. Yeah, so this is the way you can actually remember this particular expression. And if you are defining for nth orbit, again this square is cancelled by one of the R which is over here, so you can just remember it is R. So this is how we remember this electrostatic formula relation with the circular orbit. Now the second thing which here is point number 2, which we need to understand. It says electron revolves only in stable orbit. Now this stability is also explained by one of the postulates which he has taken the help of law of conservation of angular momentum, where you people know that it is mvr. Now when you talk about for nth orbit, I am going to write this Vn and Rn. What you need to understand, that Bohr has suggested that this orbital, the stable orbit, are the only one which are actually the integral multiple of h over 2 pi. So there is one particular postulate which actually justifies that why do we have the stable orbit. So first point, first postulate is about circular motion, second point about the stability, and the third point is actually about the transition. Now what do you need to remember? This transition, when it's going to be happen, remember when an electron is actually going from higher state of energy to a lower state of energy, it is going to emit the energy. And this energy, sometimes the question comes, remember it is a single electromagnetic radiation. It is single electromagnetic radiation photon. Okay, because you should not think there is a beam of electron going to be released by this transition. This is a single electromagnetic radiation, and you people should know that this photon energy, if you wanted to calculate, this third postulate is going to help you with that, which simply says that your energy, if I say this is N2 and this is N1, so whatever the energy difference you have between the two energy level, it should be equated to h mu, where h is your Planck constant, mu is your frequency, and you can remember that this can also be written as hc over lambda. So this is one particular formula which you can remember. So the third postulate which we talk about, it talk about the electron transition and the various factors which you need to consider whenever the transition of energy is going to take place. From this particular expression also you would be able to calculate the various value of wavelength or in case wave number, but that we are going to see. But for time being, what you need to remember, the three postulate and how you people need to remember. First is about circular motion, second is about stable orbit, and the third is about electron transition. This is an easy way to recall all the postulate which you people have remembered, and remember what exactly this postulate convey, because reading the statement sometimes you actually miss the application of that particular law or postulate, you can say. Here this is not a law, it's a postulate. So you need to understand that in what perspective the board has given this particular statement. Now from exam point of view, what you need to remember that there are various relations the examiner can ask you. Examiner can ask you relation like if mass has been doubled, mass has been halved, radius has been changed, velocity has been changed. So how exactly these particular factors going to change the other quantity? For that, what you need to understand when we talk about all this transition. Now I am going to explain you that based on this particular postulate, you would be able to write all these particular points that what will be the formula, and I am writing the formula for nth orbit everywhere. So for your information, if we talk about postulate 1, for we have written it as kZe square Rn, and it is equated to mvn. This is our first postulate property which tells us. Then we talk about second postulate, which is Vn Rn, and this is integral multiple of h over 2 pi, and the third is your energy transition. So this will also I will write here for your reference that this is how the postulates has been given. C over lambda is nothing, it is mu, because remember that energy is having a direct relation with the frequency, and removing a proportion sign introduce this constant. Question, if you actually if postulate 1 and postulate 2 solve together for this value of Vn, you would be able to calculate the value of this radius of nth orbit. For radius of nth orbit, when you solve, the formula which you are going to get, I am writing here the formula for you so that you should remember this n square h square 4 pi k z e square by m will be the formula for nth orbit radius. And in this case, if you actually see the relation which we need to know, we always know the relation in terms of n and z, where your n stand for orbit number, z stand for your atomic number. So what you people need to do that here, if you actually solve for h, 4 pi, k, e square, m, all these value are constants, so I would suggest you should better remember this number as 0.59, and the quantity which examiner can change is n square as it is and the value of z. It should be written in this manner, and the answer whatever you get, it is a radius, so definitely the answer is going to come in angstrom, which is actually the unit, okay, 10 raised to minus 10 meter. So remember, this is how you can calculate. The purpose here is we are not interested in the formula, because in the formula when you are writing, you can see there's a lot of variable quantity. What you can remember, you directly remember that how exactly your radius depend on the orbit number, which is n, and how exactly it depend on the atomic number. So that is the reason the n and z values are important in this particular case, which I have written, and you can see the rest, all the value when you actually solve, you get 0.59. Similarly, if I write the velocity of nth orbit, you need to understand here it is Vn, and the quantity which you will write is 2 pi, this is k z e square over nh. Now again, if you solve all the constant, let me tell you, for a constant the number which you will get is 2.18 into 10 raised to 6, which I will recommend that you people should remember, and your atomic number and n will remain there. So z and n is the relation which we need to derive. So question can comes that if a mass has been doubled, so what will happen, you can see if mass is doubled, you can see the mass is over here, the radius is a quantity which is going to be half. But when you look at the velocity, you can see in the velocity expression the mass is not only involved only. So what you need to remember, that mass is not going to be change anything about the velocity which we are calculating. So these are the kind of a question which can come. At the same time, you should be able to relate whenever they talk about a specific orbit. So see that value and you can observe the change. Now if you look at the angular velocity, I hope you people know that angular velocity is something which is known as omega n. Here let me tell you, the velocity SI unit will be meter per second. So here the unit is also important, because sometimes I actually write in SI terms and sometimes it is a different relation. Angular velocity, we know that the relation of linear velocity with angular velocity is this. So now you already have your Vn and you have your Rn. The above two expression which you have written it for Vn and Rn. What I want you to understand, that if you people simply, if we don't worry about the constant variable which we get, the thing which you need to notice is what the relation of z and the n. Now Vn is on the top, so you can see here you have z over n, and Rn is at the bottom, which you get it as n square by z. What you need to understand the relation. So if there should be no problem if I write it as that z square by n cube radian per second is what the relation of angular velocity, which can be defined with the help of atomic number and the orbit number. So guys, the point here which I am trying to explain, if you have any relation based question, you better remember this chart, because this will definitely help you to solve any question which is asked by the examiner. Now at the same time, when you have actually explained radius of nth orbit, velocity of nth orbit, angular velocity of nth orbit, if they ask you about frequency of nth orbit, I would suggest you people already know that omega is equal to 2 pi f. So you write down it as omega over 2 pi. Now in this case, you people can actually notice 2 pi is a constant, not going to be change anything. You already have omega n. That means if I forget about the variable involved over here, my relation with z and n is not going to be changed, and as it is frequency, you can write hertz for this or per second. I am getting the relation z square over n cube. Z stand for atomic number, n stand for orbit number. I have a direct relation that how this frequency is related to my atomic number and orbit number. Time period, when you talk about, I hope you people know that time period is 1 over f. So in this case, for any nth orbit, if you talk about, here what you need to take care of, that z square n cube, you have written the frequency. When you write about the time period, just flip it. So relation will look like n cube z square, and time period is definitely second. So every single formula which I am writing, the main aim is to derive a relation with n and z, which we are able to derive in this particular manner. When you talk about current in nth orbit, you need to understand when you have a charge electron moving around the nucleus, the formula we write for current is q over t, but as you know that the charge is an electron and it is moving in a circular motion, so it is written as E into T, which you can write that current if you wanted to find the current formula. Let me write it. Current in nth orbit can be written as charge multiplied by the time period is nothing, it is the frequency. So here you need to understand that in this particular case also the frequency relation, if you write it, it will be z square, whatever the constant variable, I will write it here as dotted because this is how your z square n cube will be written for current in nth orbit. So we are able to relate all the quantity, radius, velocity, angular velocity, frequency, time period, current. So it doesn't matter what exactly the examiner asks you, you people just try to relate with it. Yeah, there are a few more quantity which I will tell you over here. So we are done till magnet. Okay, now magnetic induction when we talk about, I hope people remember that magnetic induction is mu naught I over 2r, but as we are talking about nth orbit, so I will introduce the subscript in and rn. Here in this case you can see in also you have calculated, rn also you have calculated. We are only interested in the relation of atomic number and the orbit number, which is going to be come out as this way. So there should be no problem in relating directly that how exactly the magnetic induction will depend on. When you talk about magnetic moment of nth orbit, symbol is this, you have your current passing through an area. Now when you plug this value, I hope you remember this formula ENH over 4 pi m, where if you actually plug the value of 4 n equal to 1, you will find that the m1 is EH over 4 pi m, which is your Bohr magnetron, which you people have also seen this particular formula in your NCERT book somewhere. And energy of E, energy of electron in nth orbit, for that you need to understand when we talk about the total energy in nth orbit, definitely it is the sum of kinetic energy and the potential energy. Now when I write the energy, understand, I'll write in terms of K, so there should be no confusion because K simply stands for a constant over here, KZE square, and this is radius of the nth orbit. Potential energy is always written with a negative sign because I hope that you people understand that whenever some object is bound to something, the energy is written in terms of negative. So here when we are talking about potential energy, the electron is bound to the nucleus. In a similar way, when you actually see gravitational potential energy, which is also written negative because objects are bound to that particular surface of the earth. So that is the reason potential energy, when you write, it is K Z E square over radius in nth orbit. Now one interesting thing which you can notice over here, when you write the total energy is also coming out as negative, which you can remember over here. And in this case, if I have to tell you that this particular formula, you can also derive 2 pi square K square Z square e raised to 4 m over n square h square. And if you solve this, what you're going to get? You're going to get minus 13.6, which is actually the energy which you people have written in the ground state. But this z square and n square, I'll keep it here so that you people should know that rest all the value which I have written, they are constant. That's the reason I can remember this particular value. And given on particular atom, I can decide that what will be my atomic number and what will be my orbit number. Now you need to understand, especially all these results are very much applicable on hydrogen atom, because when we go for higher number of protons in one particular atom, actually this case also have its own drawback at that particular point. So here what you need to remember, one more thing, important thing, that here the 13.6 z square over n square which I am calculating, this energy is also written in terms of electron volt. So that is how the energy of orbit, the energy of nth orbit can be written. So what you can understand from here, that if I simply plug the value of z and n, I would be able to calculate the energy of various orbits. So I can plug n equal to 1, where you can see the value of n can be plugged as 1, then you can plug n value as 2, where it is 2 square will become 4. So different energy levels can be written by this formula. The beauty of this expression is that you would be able to calculate all the energy level, and I hope whichever relation I have written according to your entrance exam, these relations are very important, because definitely no one is interested in the derivation, but we are interested in the relation, how one particular quantity can be related to the other, so that you can simply see that if a quantity is written in numerator, it has a direct relation. If it is written at the denominator, it has inverse relation. And based on the power, you can actually decide that what will be the final result. Okay. Now, when we talk about this energy formula, now the basic structure which one can understand for any particular element is actually the hydrogen atom. So here I have written energy of different energy level in hydrogen atom. For that you need to understand that the formula which we have derived just now, it is minus 13.6 Z square EV over N square. Now if I plug the value of Z, especially when I talk about the hydrogen atom, and the value of Z, the atomic number is 1. So I don't have to worry about this particular numerator over here. So what is going to be happen, my final formula will look like that nth energy can be calculated by minus 13.6 electron volt over N square. Now when you actually see it over here, when I plug the value of N equal to 1, I am getting that this is minus 13.6 electron volt is the energy in a ground state. So remember, whichever electron is actually present near to the nucleus, it is the most stable state over there. Okay, when you are going to move away from the nucleus, the energy level is going to be different. But one thing which you need to notice is this, that at least for 5 energy level, you people should know the values, so that you can save a lot of time in calculation, because this is something I hope people have practiced questions for so long till now, that most of the energy level values you people remember. But I will not suggest that you should only remember the energy level, you should also remember the difference in energy level, because if you see the permutation combination over here, you just have to remember somewhere around 78 values, and that will justify the purpose. So it saves a lot of time during the entrance examination, because there it's actually key to solve questions as quick as possible. So what I'm going to show you, if you remember, the ground state energy can be calculated as 13.6 electron volt. And at the same time, when you plug the value of N equal to 2, the energy can be written as minus 3.4 electron volt. When you talk about the difference between two energy level, so you can see this difference come out as 10.2 electron volt. So it will be good if I remember this energy difference also. When I go for the value of N equal to 3, I can plug the value of N equal to 3, it will become 9, so 13.6 divided by 9 will definitely give me some answer, and that answer comes out as 1.51 electron volt. One more thing you need to understand, sometimes the value of N which you are going to plug in such a manner when examiner says it is from second excited state. As we have mentioned that N equal to 1 is your ground state, and your first excited state actually starts from N equal to 2. So when they say N value as second excited state, the value of N should be plugged as 3. So this is a one simple relation which you people should be able to relate. And one more thing, if you take a difference of 2 and 3, here you will get 1.89 electron volt. Again, if I plug the value of N equal to 4, it will become 16, 13.6 divided by 16. This energy difference between 3 and 4, if I talk about, it comes out 0.66 electron volt. Similarly, if I write the value of 5, it is minus 0.54. The difference is 0.31 electron volt. So guys, you can remember not only the values of E1, E2, E3, E4, E5, but also remember the energy difference. Because when you talk about the excited state, or you can say when you talk about the ionized state is actually the one where the electron has been ejected from the orbit. In that case, you simply consider that energy is actually going to be 0. Because N equal to infinity, infinity simply means that energy is going to become 0, because you are dividing anything by infinity will definitely give you a 0. So what you need to understand when you look at this particular energy level diagram of hydrogen atom, one thing you can notice that once you are going far away from the nucleus, the gap between the two energy level is actually decreasing. So that is basically the reason you can see initially the energy difference which you got over here, it is 10.2 electron volt, and that energy difference keep on decreasing. So that is also something which is quite noticeable over here. There is one more thing I would suggest that you people should also remember few more value, like if a transition happens from 4 to 1, in 4 to 1 the energy difference is going to be 12.75 electron volt. Okay, if a transition happens from 3 to 1, in case of 3 to 1, you remember it is 12.09 electron volt. And if a transition happens, I will write which one, 4 to 2 also, one more thing which we can notice over here. So 4 to 2, your transition is going to become 2.55 electron volt. So guys, the point here is I have written some 5 energy values. The difference, if you notice, 1, 2, 3, 4, 5, 6, 7. 7 plus 5, you can remember at least 12 values, and definitely let me tell you that if you remember this energy value and the difference, the life is going to be easy, because you people would be able to directly substitute this value, because this is a very common hydrogen atom structure which we use during the entrance. So you don't have to worry about the values. So at least when you keep on practicing the question, this value should be known to you. I will not recommend that you should waste time in calculating this value over there. So you can directly use the value in case if you know it. And that is what I will recommend during the entrance examination. So guys, this is my discussion on hydrogen atom, which is a very basic question which comes during the entrance examination. Now let me explain you a few more terms with respect to this atomic structure. Now when you talk about excitation and ionization of an atom, now you should be very clear with the excitation, because excitation simply means the transition from lower to higher orbit. That is what you mean by excitation. And the same time when you talk about ionization, ionization means when an electron has been ejected from its orbit. So this ejected electron, which I am writing here, ejection of electron, which you can understand that it can happen from where? This transition, remember, it can happen from any orbit to infinity. So that is what you mean by excitation and ionization of this. There is one particular thing which you need to understand, that there are two ways in which energy can be supplied. So if I write here, there are two ways in which energy can be supplied. So these two ways which you need to remember, because one of the way you are very much familiar with, supplied for excitation and ionization. You need to remember the meaning of excitation and ionization, which I have written on the top, that one energy can be provided which is by photon, and the other way we actually provide by collision. The one thing which you need to remember, mostly the collision questions comes in advanced or mains, but here this one is a very common phenomena. I'll also explain you by the end of this lecture that what you need to understand by the collision term also. But what fundamentally you people need to understand, that when, if you have your energy level diagram, let me assume this is n equal to 1, n equal to 2, and this is n equal to 3. You have some electron present over here in a ground state, and if an energy is provided to it by some photon over here. If this energy provided, let me take two cases. This energy provided is 12.09 electron volt, or it is 11.0 electron volt. So I have taken two energy which can be provided for this particular electron. Now what you need to understand over here, if you people have noticed carefully that I have given you the energy difference. So when you talk about energy difference, I think 1 to 3, energy from 1 to 3, when it happened, the transition is having a value of 12.09 electron volt. And when the transition is going to happen, because there is two So 1 to 2 require an energy of 10.2 electron volt. The beauty of this particular expression, you need to understand that the electron will accept the energy which matches exact difference of the energy level. So here when you actually project it with the two energy level, the one which it is going to be accept is this one, because this 11 point electron volt, you can't say that 11 point electron volt is actually more than 10.2, so there is a chance that electron can go here and it can come back. No, it will never happen. There is no possibility that electron can exist between the two energy levels. So you need to be very much sure that this 12.9 is provided, then only it is going to jump from the first energy level to the third energy level, and this 11.01, the energy, it is going to be simply passed through, so this energy is not going to be accepted by this particular electron. So the basic fundamental thing which you need to understand is what? That electron will accept the energy which matches exactly the same energy difference between the two energy level diagram. Now one more thing you can notice over here, if anything is provided more than the ionization potential. Now if supplied energy is more than ionization potential, for that you need to remember that whatever the remaining energy you will have, that will simply become its kinetic energy. So if you have a case where the energy provided more than 13.6, you need to understand that whatever the remaining energy, you can simply equate it to the kinetic energy formula, which is half mv square, and you would be able to calculate that by what velocity that particular electron will move. So these are some basic terms which we need to understand, and I hope everything is clear when it comes to the excitation and ionization of an atom, and this is what you need to remember over here. Now when you talk about the next, frequency and wavelength emitted, this is also something which you people need to understand, that when we talk about an electron which is present in the higher orbit, definitely it come back to a stable form by emitting a photon energy. Now there can be questions based on this photon energy which you people would be able to solve by using the third postulate. When I say frequency and wavelength of emitted radiation, what you people can use, that this photon energy, if you wanted to calculate, you better take help of the formula that change in energy from N2 orbit to N1 orbit can be equated to h mu, or you can say hc over lambda. Basically examiner is more interested in this wavelength value, so we will go according to that. In that case, you know, this energy which you people can write minus 13.6 z square over n2 square, then I am writing minus 13.6, you already have a minus sign and this is also minus, it will become plus, so n1 square and this is z square equated to hc over lambda. So what will happen over here, this I am writing hc over lambda over here, 13.6 z square, you take it as common, inside you will have 1 over n1 square minus 1 over n2 square. So that n1 minus minus will become plus, and one thing you can see, that 1 by lambda, the wavelength can be calculated by 13.6 z square, and you can take this hc over here. And I hope you people remember one particular thing, that this hc which I am writing and the value of z, if atomic number is given to you, you would be able to calculate any wavelength, because you people have to remember that this 13.6 hc is nothing, it is your R value, which is known as Rydberg constant, and similarly this formula is known as Rydberg formula. So this is something very common over here, you can remember. This R will stand for Rydberg constant, and this is your Rydberg formula. I hope you people are aware that the value of R is 10967800, but we can take approximation as 10 raised to 7 per meter. So this is the way you people can actually calculate. And for one more thing, that I hope you people are aware, that there is something V bar. This V bar is actually which is known as wave number. So be very careful that what exactly the examiner want you to calculate, and you can calculate this particular wavelength from here. There are few more possibilities, so every time I will not suggest that you should be completely rely on this particular formula, because I want you people to understand that there is also one alternate way available over here, and you can make use of this formula whenever it is possible, because it is definitely going to reduce your time and you people can actually make use of this formula. So if you are calculating wavelength, be very careful that if you are calculating wavelength and somehow you people know that you know the energy difference. So what we can do over here, if delta E is h mu, which can be written as hc lambda, lambda can be written as hc over delta E. This delta E values, remember that you have to plug in terms of electron volt, because the value of wavelength which you people will calculate, let me tell you, hc, it's again a constant, and you can remember that this is 12431, and this delta E, whatever the energy difference they have given to you, or somehow if you can remember from the energy level diagram which I have drawn, you directly substitute the value of delta E over there. So there are various transitions where there are somewhere around 13 value which I told you to remember, and if you remember any of the transition which has been given over there in the previous slide, you can use it directly over there to calculate this value of lambda. Go for it, because you can see that how much time we will save over there, and you will directly get your answer by simply dividing the delta E by the value 12431 over delta E, and the answer will come in terms of angstrom. So remember that don't make a mistake of taking a wrong unit, because this formula which I am deriving, you have to be very careful whether I have written in terms of electron volt, whether I have written in terms of angstrom. It's important, because everywhere we are not deriving the formula, or I am not giving you the keys in terms of SI unit, which in this case will be 10 raised to minus 10 meter of electron volt. You can convert it into joules also. So you have to be very careful, but the reason for giving this formula in terms of electron volt and angstrom, because most of the time what will happen in the question, the value which will be given to you, it will be given in a similar manner. So I hope you understood my point and what exactly you can do to solve question in a much more better and efficient way. Okay, you have to be more efficient when it comes to the question, and always make sure the trick should be used in such a manner that you should be able to reach to the final answer in a very short span of time. That is all about entrance. De-excitation of an atom, this term is also important, because let me tell you that de-excitation, now I hope you people are aware that nobody wanted to stay in a state of excitation all the time. This is the same thing when you have an electron which is going from its lower state to a higher state. This time period which is going to be spent over here, it's very less, because this lifetime, let me tell you, this lifetime which we have, which is spent by an electron in a higher state, the maximum value of this lifetime is somewhere around 10 raised to minus 8 seconds. So you can imagine what short span of time it is going to be stay in excited state, and it will stay there only when there is no other alternate option available to this electron that it can come back to a lower state orbit. But if the option is available, definitely it is going to come back, and in that process is going to release some kind of energy, photon energy, for which we have seen the formula that how we can calculate wavelength. So you people have to remember that after lifetime of excitation, I have already written the value. After lifetime of excitation, an electron transit to any of lower energy level. So you have to be very careful with this particular method. So by definitely when it go back to the lower orbit, whatever the excess amount of energy it has, it is going to be released in terms of photon, and there are various values can be calculated for that particular photon. You people have to remember one more important point over here, that number of possible photon energies emitted due to de-excitation. I will write it over here, but you people better make a point of it, that number of possible photon energies emitted due to de-excitation. Remember the word, I have just now explained you what do you mean by de-excitation, from n orbit. In this case it is actually I have taken n2. States are, this formula is very handy, so you can say it is n2c2, which you can remember as n minus 1 by 2. Yeah, I hope you people are familiar with this particular formula as well, because this is something which also gives you number of lines of spectra or number of spectral lines. So this question can also come, and I hope you people are able to relate that what exactly I am talking about. So when it comes to the de-excitation state, because when you draw the energy spectrum diagram, I hope you people have noticed that there are various lines which we draw. So first line which you draw is the higher energy and then lower energy. So this number of energy line which you draw, it can also be calculated by this formula, and sometimes the question actually depends on that. So you people have to be very careful that what exactly the examiner wants you, because you need to remember one thing, that whenever an electron goes to the excited state, there is no particular way that it is going to come back. If you have various energy level present in between, it can go to the second also, it can go to the 1, or it can directly go to the 1. So till the time it will keep on finding its most stable energy, it is going to keep on releasing and it will come back to the most stable energy. So here you need to remember, from state n, this is also important, from state n, possible spectral line which can be emitted. If you wanted to calculate possible spectral line which can be emitted, for that you can use the formula which I have given, this. Okay, because this is also, sometimes they will give you the number of orbit, and you people should be able to calculate that how many spectral line can be drawn for this particular case. There is also one more thing, that maximum possible photon. If they ask you the maximum possible photon, if you have to calculate, remember that maximum possible photons emitted can be simply calculated by this particular formula for one atom, which is going to be n minus 1, which is pretty basic, which you people can easily remember. So these are the two types of question which can comes when it comes to the maximum spectral lines emitted by an atom. So you should remember what exactly you people have to use, because when you actually talk about the series diagram which you have in your book, and you people have also noticed that series diagram, there we have seen that whenever an electron actually fall back to the ground state, that particular series is actually studied by Lyman. We call it as Lyman series, and this Lyman series is actually fall in ultraviolet region. Similarly, when it actually fall in the first excited state, which has been studied by Balmer, which is called as Balmer series, which is also the photon, you can see it falls in the visible range. Then you people have Paschen, Brackett and P fund, which actually falls in the infrared region. So these are the various spectrum which you people have seen in the regular class as well. You need to remember that when you actually talk about Lyman series, you should always remember that it actually, the value of n which you are going to take, it is actually the ground state where you can plug the value of n as 1. In case of Balmer, the value of n for which the energy or the electron come back is 2. So from whichever energy they actually ask you, sometimes they can also mention the name of the series, and you should be able to plug the value of n. And the formula we have already seen, the Rydberg formula. From there you would be able to calculate the wavelength of this particular case, that how exactly it can be calculated. So the various question which examiner is going to be formed, it based on the relations which we have seen, it based on the spectral line diagram and the energy level diagram. Energy level diagram is one particular diagram which you people need to understand, because it is the most important in terms of this particular chapter, because you can see there are not many values you need to remember, but if you mug up all the difference in the energy level diagram, there are a lot of questions which are going to be very easy, and you can do those questions in just few minutes. okay, and that saved time definitely can be utilized somewhere else. Okay, now if you are clear with this particular spectral diagram, there is one particular term which I have used in the beginning, that an electron which actually receive energy in terms of photon, or there is also one more possibility that it receive an energy in terms of atomic collision. Atomic collision, we need to have a basic understanding of atomic collision, because you need to understand when you talk about collision, there are various cases which we can discuss about it, but for NEET point of view, you people should at least know that what exactly, because sometimes they can frame a simple question even if they don't make it like a very difficult question like JEE Advanced, where a lot of calculation can be involved, but in NEET point of view, the question can be very easy. So I'm going to try to explain that what exactly this atomic collision means. You people have a basic understanding of collision which you people have learned in grade 11. There are two types of collision, elastic and inelastic. What do you need to understand when you have N1 and N2? Let's say there is one particular electron which is present over here, and there is going to be energy supplied by this electron, and when this electron is projected on this, and depending on the impact parameter, you need to decide that what exactly is going to be happen. So definitely here what happened, if you have, I told you that energy differ on the basis of impact parameter. If in this case, if it is a case of elastic collision, then you can say that whatever the energy belongs to this, I'm writing it as E naught, definitely the entire transition of energy will take place, because in elastic collision we don't consider any kind of a loss of energy, and you people know that in atomic physics the collision which we consider between the particle, it can be considered as elastic. Inelastic is the one where there is a loss of energy happens, and there are various ways in which energy can be lost. But if it is a case of elastic collision, you can simply say whatever the E naught value has been given to you, and accordingly you can decide that which energy level this particular electron can jump into. So here you need to understand one thing, if the impact parameter is changed. If impact parameter is changed means if it is not a case of elastic collision, then what will happen? If it is not a case of elastic collision, then I will write a specific note for you people that you need to remember, that in that case, in above collision, the supplied energy which you're going to have, the supplied energy of electron can be any fraction of E naught. For that, what you need to understand, that if the maximum energy is given as E naught, it can be any fraction which is possible for the electron, which it can take, it can go. So which will be decided. Let me give an example that it will make things easy for you to understand. If I'm considering that n equal to 1 and this n equal to 4, and here you have an electron present and you are going to supply it energy, suppose an electron which is having an energy of 12.9 electron volt. Now you people know that n equal to 4, if I write the value, I hope you people now know that energy difference between 1 and 4 can be written as 12.75 electron volt. Energy difference between 1 and 2 can be written as 10.2 electron volt, and energy difference between 1 and 3 can be written as 12.09 electron volt. Now the given amount of energy which you can see, it is 12.9, and based on this, now there is all the possibility that if it take, because 12.75 is actually the energy required to jump into the 4th orbit, which definitely can take place in this particular case, because I told you it is the fraction of energy which is going to be taken. So it can jump into any orbit which is having its energy level below 12.9. So 4 is possible, definitely your N3 is also possible, your N equal to 2 also possible, because all these things can be defined in terms of energy difference. So in atomic collision, when we talk about, what you need to understand that this energy difference, the main important point which you have to take from atomic collision is what? That whatever the maximum energy the electron possess, okay, any particular level below that maximum energy level can be taken by the electron when it go from a lower state of energy to a higher state of energy. Now basically in this particular part I have covered everything about the atomic structure, and I hope if you people actually go through this particular part again and again, there is no such question you will find which you not been able to do with these number of formula which are available to us. So we have a very elaborative discussion on atomic structure, so I hope it will help you during your NEET exam preparation, and you people can solve various number of questions where you can actually see that wherever you can use the direct approach of this formula you can use, wherever there is a direct relation you can use, you people can actually do it over there as well. So this is my entire discussion on modern physics. I hope you people will prepare dual nature of matter and radiation and the nuclear part, because there are various things which are involved in that particular chapter also, but those, if you see the quantity wise, they are very small topic. You can give it a reading through NCERT book, you would be able to do most of the questions based on that. Now this is my last session. I am wishing you all the best for your NEET exam. Just keep on preparing, do well, and that's it from my side. Hope you guys have enjoyed the session. We'll definitely see you somewhere in the future. Bye bye.